Hi everyone. In this video we will talk about covalent bonding. So we have talked about ionic bonding, we have talked about metallic bonding. Again, metallic bonding is not a chemical bond. Ionic bond is a chemical bond. So there are basically two types of chemical bonds that we talk about. One is ionic and the second one is covalent. Ionic bonds are formed between metals and nonmetals. Metals lose electrons, nonmetals gain electrons. So you have cations, we have anions. Whereas, speaking of covalent bonding, these bonds are found between two nonmetals. Okay, both elements got to be nonmetals. So I hope you remember where nonmetals are in the periodic table. Okay, so this part of the periodic table are the nonmetals. Hydrogen is also a nonmetal. So that means the bond will be formed between these elements. And as you know, group 18 does not make any bond. So group 18, we're not talking about group 18. It's only like phosphorus, oxygen, nitrogen, sulfur, carbon, silicon. I mean, it's these kind of elements that we're talking about. So these bonds are formed by sharing electrons because nobody is willing to lose. Again, if you remember, we talked about valence electrons. Okay, so nonmetals have higher number of valence electrons. Uh, we have group 13, 14, 15, 16, 17, and of course 18. So if we talk about valence electrons, how many valence electrons each has? We have 3, 4, 5, 6, 7, and 8. So somebody like fluorine who already have 7 valence electrons, they just need 1 to complete the octet. Okay, so they don't need to be losing or gaining anything. If they're bonding to another non-metal, all they want is to share because nobody's willing to lose. So if a bond is formed between non-metal and a non-metal, since they both have higher number of valence electrons, no one is willing to lose. So they end up sharing it. And the concept of sharing is that their valence electrons come close together. So this is the fluorine. So you have another fluorine. So the valence electrons come close together. They kind of overlap. Okay, and when they overlap they share the electron that needs to be paired. So the way we show it by a line. So there is a one valence electron from the unpaired electron from this fluorine and one from that, so we show a line. So this line shows sharing of electrons. So each line shows two electrons, okay, that are being shared between two atoms. You also must understand that these two electrons are held by the nuclei of both fluorines. So this nucleus is holding it because electrons are negative, nucleus is positive. This nucleus is holding it and this nucleus is holding it. So they're pretty much they will stay at their place. They are not free to move. These electrons are free electrons. They can move much more than these electrons because these electrons are held by the two nuclei. Okay, so they're bonded electrons. They are called bonded electrons. So one more time, let's say hydrogen and hydrogen. So nobody's willing to lose here, so we'll say, okay, let's share it. So this line is called sharing or covalent bond. So each line represents two electrons. Let's say I have oxygen. So oxygen has 1, 2, 3, 4, 5, and 6 valence electrons. So if I want to make a bond between oxygen and oxygen, they share this electron, okay, but they don't have 8 yet. It is 2, 4, 6, okay, and 1, 7. So 2, 4, 6, and 7. So what happens is that these electrons come in the center and you share another pair of electrons. So then two lines represent 4 electrons because each line represents 2 electrons. So we call it a double, okay, double covalent bond. So there is a single covalent bond and then there is a double covalent bond. So anyway, covalent bond is formed by sharing of electrons. Let me not get off the topic here. Sharing of electron, no transfer, no positive, no negative, and we call them molecules. Okay, if you remember, for ionic compounds, we use the word formula units. But for compounds, for covalent compounds, we use the word molecules. Okay, they don't simplify the formulas. In ionic compounds, I said that if we have PB2O4, we had to simplify the ratio. So the formula was going to be PbO2. Whereas for covalent compounds, we do not simplify the formula. It will stay as is. Like if it is N2O4, I will keep it as N2O4. All right. So there is a difference between ionic bonds and covalent bonds. We simplify the ratio for ionic. We do not simplify the ratio for covalent. We use prefixes for naming these compounds. There is no crisscross method. There is no ion. There is no charge. So we will use prefixes. And the second element will still end up with the name of ID. They have strong bonds. So covalent bonds are very strong bonds because, as I said, that the two nucleus from each side is holding the two electrons. So whenever we make this covalent bond, they're very strong bonds. Okay, we call them intramolecular bond. Intramolecular means the bond that is holding two atoms together. Okay, a bond that holds two atoms together. So the two types of intramolecular bonds we have learned are ionic, okay, and covalent. So they're very strong intramolecular bonds, but they don't conduct electricity because they do not turn into ions. All right, so there are no ions in this solution. So that's why it doesn't. So since it doesn't dissociate, it does not current electricity. They're typically weak intermolecular bonds. Like if you have this fullerene, and then there is this fullerene, okay, and then I have another molecule of fullerene right here, okay. So the intermolecular bond means a bond that holds these two together. So this is called intermolecular bond, right? Intermolecular bond is this one right here. So they have weak intermolecular bonds, but they have strong intramolecular bond. This is intramolecular bond. So make sure you understand the difference. Intra means within the molecule, inter means between the molecules. So weak intermolecular forces, bonds, and stronger intramolecular bonds. They have low melting and boiling points because they're usually gases. They're not holding each other very tightly. Since they're not holding each other, they're weak intermolecular bonds, I can easily separate them. So since I can easily separate them, that means I can easily turn them into a gas or from solid to a liquid. I can easily break this force and separate the molecules. So the boiling point and melting point depends on the intermolecular forces. Keep it in mind. They depend on the intermolecular forces. The stronger the intermolecular forces, the higher the melting and boiling point will be. The weaker the intermolecular forces, the low will be the melting and the boiling point. So going over it, covalent bonds are formed between two nonmetals. All right, so the bond will be formed between the elements on the right side of the periodic table. They are formed by sharing of electrons, not transfer of electrons. Okay, we use prefixes, not the Roman numerals. They still end up with IDE, and they have low melting and boiling point and weak intermolecular forces. Let's start talking about naming covalent compounds. So as I said, we use prefixes. So these are the prefixes that are used to name the compounds. So we use mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. These are the prefixes you need to memorize. I hope you already know them. Always use prefix to tell how many atoms are present for any particular element. We don't use mono for the first element. Okay, this is only used for the second element. I will just explain what I mean in a second. So let's say you have N2O5. So since you have two nitrogens and two is di, okay, so it will be dinitrogen and 5 means penta. So dinitrogen pentoxide. Now you have one carbon and one oxygen. So I will not use mono for carbon. I will just say carbon, but I have to use uh, you have to I have to use prefix for the second element. So I will say carbon monoxide. If it was CO2, okay, I will say carbon dioxide. Okay, so let's do some practice. If it is PCl3, I will say phosphorus, phosphorus trichloride. Okay, so there is, I'm not using mono for the first element. But if the first element is more than one, so let's say if it is N2Cl3, I will say dinitrogen trichloride. Okay, and also I mentioned that we don't simplify the formulas. So it will be dinitrogen, okay, dinitrogen tetroxide. So we do not simplify the ratios here, just like we do in ionic compounds. No, this is how you not name the compounds. It's very simple. You just write what you read. What you see. You see two nitrogen, so you say dinitrogen. You see three chlorine, so you say trichloride. And writing the formula is even simpler. Okay, so let's say you have to write the formulas. So it is carbon, so you write carbon. Then it is dioxide, so it's O2. So we don't crisscross it. Phosphorus is phosphorus. Trichloride means Cl3. Dinitrogen is N2 and trichloride means Cl3. Again dinitrogen N2 and tetroxide means O4. So there is no crisscross the way it was in ionic compounds. So covalent compounds are much simpler to name and to write formulas. You have to use prefixes. We do not simplify them. You just write as you read. So that's all about covalent compounds, and just go ahead and practice on your worksheet. Thank you very much.